Hello, this is Maestro Maravilla. We are going to be working on lesson number 4 today when we are in module 2, and this is 6th grade math. Okay, so let's get going. So, lesson number 4, it's called interpreting and computing division of a fraction by a fraction. Okay, so for this lesson, first of all, the one thing that I want to talk about here is that when we talk about equivalent fractions, okay, so equivalent fractions, as here, equivalent fractions, right? Because we have 2/3 and we're supposed to write it through equivalent fractions for each of the fractions below. Okay, equivalent fractions, if you remember on module number one was about ratios, right? And so the ratios, we learned that, let's say that you have 1 apple to 3 oranges. Then on the next round, you'd have 2 apples to 6 oranges. And then on the next one, 3 apples to 9 oranges. Okay, so this is from module 1, ratios, right? Now, the other thing to keep in mind is that equivalent fractions are just like ratios, right? If you actually take the 1 to 3 and make it into a fraction, 1 to 3, then the next one here, the next is an equivalent fraction. So this is equal to 2, 6. And the next one is also an equivalent fraction. So this is equal to 3 ninths. So in essence, ratios are really just equivalent fractions. So if we have 2/3 and we want to write an equivalent fraction, we can pretend it's like a ratio, right? So like pretend that it's, 2 apples to 3 oranges. So on the next one, it would be 4 apples to 6 oranges. The next one would be 6 apples to 9 oranges, right? And the next one would be 8 to 12 and so on, just like we did in module number 1. So then we can multiply 2 times 2 here and make it a 4, 3 times 2 here and make it a 6. That's our second round right there. You'll see this an equivalent fraction. Then on the next one, it could be 6 ninths. That's what we have right there. Right, we multiply 2 times, so if we multiply it times 2, we get 4, 6. If we multiply it times 3, we get 6 ninths, right? Because 2 times 3 gives you 6, 3 times 3 gives you 9. So if we do another round, multiply it times 4, then we can multiply 2 times 4, and that's going to give us 8. And then we can multiply 3 times 4, and that's going to give us 12. Okay, so again, equivalent fractions are very like those ratios from module number 1. Okay, so we're there. So then if we look at the next one is 10/12. 10/12 can actually, if you remember, we learned a concept in ratios called the value, right? So in other words, the value means to have the ratio in its simplest form. If we think about this fraction 10/12 and having it in its simplest form, then we can actually break the 10 and the 12 in half. And we can say, well, if we break the 10 in half, that's 5. Break the 12 in half, that would be 6. So it's 5, 6. Right? So then on the next round, then you'll have 10/12. But your value is 5, 6. Right? So then the next one, this would be when you multiply times 1. This will be when you multiply times 2. When you multiply times 3, you'll get another equivalent fraction. And that would be 5 times 3 is 15. 6 times 3 is 18. If we continue, we can say times 4. So then the next one would be 20 to 24. We can continue and say times 5. So the next one would be 5 times 5 gives you 25. 6 times 5 will give you 30. Do times 6. So the next one would be 5 times 6 is 30. And then 6 times 6 is 36. So notice that for the numerator, each time it only increases by 5. So 5, 5, 5, 5, 5. So we're looking at its value, right? And then the denominator increases by 6, 6, 6, 6 each time. and they're all equivalent fractions. All of them are equivalent fractions. So in essence, equivalent fractions are really like ratios, very much similar to those ratios. Okay. Okay, so let's go to example number 1. Molly has 1 3/8 cups of strawberries. She needs to make 3/8 cups of strawberries to make 1 batch of muffins. So then how many batches can Molly make? Well, if we make sense of this, out of this 1 3/8 of cups of strawberries, she needs to take out 3/8 each time to make 1 batch of muffins. So we need to divide. We need to divide 1. Oops. We need to divide 1 3/8 by 3/8. Okay, so we need to make that division. So then in order for us to do this, we can build a model. But before we build the model, let's go ahead and make this mixed fraction into a proper fraction. Okay, so then what we're going to do here is we're going to multiply 8 times 1, and then we're going to add your numerator. So this is equal to, okay, so 8 times 1 is 8 plus 3 is 11. So that's going to give us 11/8 divided by 3/8. Okay, so let's go ahead and draw a model. Now I'm going to draw this model based on my first fraction. So I need 11 out of 8 pieces. So what do we do? Okay, so we draw a tape diagram. Okay, so we go this way. And then we go this way. Okay, maybe we can do 1, 2, 3, 4, 5, 6, 7, 8. So we'll stop right there. Let's fix it. Okay, so that's 8 pieces of 8. Okay, but I need 11, so that's not enough. So I need another 8. So let's do another 8. Okay, so we'll do 1, 2, 3, 4, 5, 6, 7, 8. And then we close the model here. But now remember, I'm going to shade in 11 out of 8. That's what I'm going to shade in. Okay, so I'm going to shade in 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's not enough, so we need to shade a couple more to get to 11. So 9, 10, and 11. Okay, now I'm going to break those into chunks of 3/8. Okay, so I'm going to break those into chunks of 3/8. So then I'll grab 1, 2, 3, and that's 3 out of 8. Okay, so that right there is 1 batch of muffins. That's 1 batch of muffins. So then 1, 2, 3, that right there is another batch of muffins. Okay, now then we're going to grab 1, 2, and then we're going to borrow 1 from the next one. That's 3 out of 8, and that's another batch of muffins. I want you guys to understand here that obviously for the first, from here to here, okay, I shaded 3 out of 3, and that makes 1 batch of muffins. And then the next 3, I shaded 3 out of 3, that makes another batch of muffins. I borrow from a second one to shade 3 out of 3, and that makes another batch of muffins. But remember that I need 3 out of 8 to make a batch of muffins. So I'm going to grab 1, 2, 3. Now you'll notice that this next one isn't quite 3 out of 3/8, or I'm only able to shade 2 out of the 3. So I'm only shading 2 out of the 3. So I can't quite make 4 batches of muffins, but I can make 1, 2, 3 plus 2 out of 3. So then my answer here is I can make 3 batches and then 2 out of 3. Okay, and that's my answer there. All right. And we know this also, if we solve once you have your division problem, once you see that your denominators match, see here at the top how you have 11/8 divided by 3/8. When you're dividing fractions and the denominators match, the denominators are the same, then your answer is really your numerators. Okay, so your answer is going to be the numbers at the top there. So then your answer, it would be your first numerator divided by your second numerator. Okay, because this 8 will just cancel out, and then your answer is 11/3. Now you'll simplify this. You'll say to yourself, how many times can the 3 fit into the 11? And the answer is I can fit 3 times, right? Because 3 times 3 is 9. But then there you have 2 more to get to 11 and 2 out of 3. And there's your answer, and my answers do match. All right, so that was example number 1. And one thing I forgot to say is to actually write the answer. The answer is Molly can make 3 2/3 batches of muffins. Okay, so there's my answer. Okay. All right, so let's go ahead and move to example number 2. Molly's friend Xavier also has 11/8 cups of strawberries. But now look, he needs 3/4 of a cup of strawberries, and he's making, to make a batch of tarts. He's making tarts. So then how many batches can he make? Okay, well, to solve this, we're gonna do is we're gonna first of all understand that we have 11/8 cups of strawberries divided by 3/4. Why? Because I have 11/8, and then I need to take 3/4 from there so I can make a batch of tarts. And so the question is, how many batches then can Xavier make? So then what we are going to do is we're going to make equivalent denominators. And so we notice here that my denominators is an 8 and a 4. Okay. So the 8 can't make it smaller, right? But the 4, I can make it be an 8 so it can match the one on my first fraction. And I can do that by multiplying by 2. Whatever I do to my denominator, I must also do to my numerator. So then I'll rewrite my fractions. I'll keep the first one, 11/8 divided by, and then 4 times 2 right here is 8. And then 3 times 2 right there, it's 6. So 3/4 and 6/8 are equivalent fractions. Okay, so but now you'll notice that my denominators are now the same. And when my denominators are the same, then my answer is really my numerators. Then I look at my 11 divided by 6, and that's really my answer. It will be 11/6 because the 8s are going to cancel each other. So then my answer is my first numerator divided by my second numerator. So I can simplify this and say how many times can the 6 fit into the 11? It fits 1 time, but you have a remainder of 5/6. Okay, now we're going to let's do a model. Okay, we're going to do a model based on the part where I had equivalent denominators. Okay, where I had them right there. So then I'm going to go ahead and break this into 8. So let's do 1, 2, 3, 4, 5, 6, 7, 8. Close it, but it's not enough because I need 11. Okay, so it's not enough. So then I'm going to make a second whole, and that needs, I need 8/8. So 1, 2, 3, 4, 5, 6, 7, 8. Close it. Okay, and now I need to shade in 11. So let's go ahead and shade in 11. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this time I'm going to break them into pieces of 6/8. Okay, so then I'm going to go ahead and I still have 1, 2, 3, 4, 5, 6. Okay, notice that I have 6/6 shaded, 6/6. And this represents 6 out of the 8, right? Remember, because from here to here, it's one whole, right? And then from here to here, it's my second whole, right? So then I'll grab another 6, right? So I'll have 1, 2, 3, 4, 5, 6. But I want you guys to notice that I actually had to go all the way here because I need to be able to shade 6 out of the 8. But in this case, I only have 1, 2, 3, 4, 5 out of the 6. 5 out of the 6. So I don't quite have the 6 out of 6. So I can't make a second batch of tarts. So how many batches can I make? Well, in reality, I can only make one batch. Okay, which is this one right here. But then I can't quite make a second one because I'm missing this one here to the right. So then I was able only to make one. And then I was able to shade 5 out of the 6 for the second batch. So that's how many I can make, and there's my answer. Okay, so there they are. So then I can say that Xavier has enough to make 1 and 5 out of 6 batches. Okay. Another way to think about this is you have, if you have 11 eighths divided by 6 eighths, this is like saying 11 eighths divided by 6 eighths. Well, what you'll do here is the eighths will cancel, and then you have 11 divided by 6. 11 divided by 6, which is equal to 1 and 5 over 6, which is essentially what we did up here as well. Okay. Okay, so that was example number 2. We're going to move on to example number 3. But one thing to keep in mind before continuing with example number 3 is that for the previous problems we were doing, so for example number 2, this was a measurement division. Okay. Example number 1 was measurement division. Now, for example number 3, let's do something different. Let's do partitive division. Okay, so we're doing partitive division for example number 3. Now, the way that works is, obviously, I can see what my answer is there because my denominators match, right? And because my denominators match, then I can see that my answer is simply my first numerator divided by my second denominator, and that's my answer. There's 3, right? So I can just look at it and figure out what the answer is without really doing anything. But if I want to use partitive division, then what I will do is I will actually take the second fraction and do my model based on the second fraction as opposed to the first fraction. Okay, so I'm no longer going to be doing this model based on the first, but on the second, because this is partitive division. So then what I will do is I'll draw the model and I will do 2 out of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my 8 pieces, but my second fraction says I need to shade in 2 of them. So I'm going to shade in 1, I'm going to shade in 2. Okay, now those 2 represent what my first fraction says. They represent 6 out of 8. So these 2 right there, they represent 6 out of 8. That's their value. So if they represent 6 out of 8, then what's the value for the whole thing? What is the value for the whole thing? And this is partitive division. So the way I will do this is to think about it, right? If these 2 pieces are worth 6 eighths, what happens if I break 6 eighths in half? Then what's the value of each one of these 2 pieces? Well, 6 eighths divided in 2, that would give me 3 eighths. So then this tells you that each one of these squares, it's 3 eighths. 3 eighths and 3 eighths, right? And it makes sense because then both of those combined will give me 6 eighths. So if this is 3 eighths and this is 3 eighths, then every single little square must also be 3 eighths, 3 eighths, 3 eighths, 3 eighths, 3 eighths, 3 eighths. So then I'll just do the math, right? 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 3 is 21, plus 3 is 24. So then I have 24 eighths. If I simplify it, then I tell myself, okay, how many times can you fit that 8 into the 24? And the answer is 3. Okay, so once again, this was the partitive model as opposed to measurement, like we did in the previous 2 exercises. Example number 4, we are going to continue using the partitive division method. Okay, so the partitive division method. And so for this one, we look at the second fraction as opposed to the first one in order for us to draw the model. So it tells us the first fraction there, 2/3, tells us that we have to draw 2 out of 3. So let's make the model. So we have this model, and this model, and then we break it. Okay, so there's my 3, and I need to shade in 2 out of the 3. So I'm going to shade in 1, shade in 2. Okay, so I'm shading those 2, and then it tells me that those 2 out of 3 have a value of 3/4. So those 2 have a value of 3/4. Okay, so then I need to figure out, I need to break this 3/4 into, so I can give the value to each one, and then I can figure out what then the whole thing is. Okay, so how do I do that? Well, I know that those 2 are worth 3/4, so then I have to break them in half. So I have to divide by 2. So then I can find the value of each one of these 2 little squares. So what do we do here then? We keep the first one. Okay, we change from division to multiplication, and then we do the reciprocal. Remember, there's a 1 under the 2 to make it a proper fraction. So then we flip it over, do the reciprocal, that's 1/2. So then we just multiply across. 3 times 1 is 3. 4 times 2 is 8. So then that tells you that each one of those little squares has a value of 3/8. And therefore, this is also 3/8. And therefore, the last one is also 3 out of 8. Now you add them all together. 3 plus 3 is 6, plus 3 is 9. So then your answer is 9/8. You can simplify it. You can say how many times can you fit the 8 into the 9, and you can fit it 1 time, but you have a remainder of 1/8. Okay, so there is example number 4. For exercises 1 through 5, we're going to go ahead and do measurement. And for measurement, usually what we do is we find common denominators. And we do this by creating equivalent fractions. Okay. So then we look at the first one. The first one is 6/2 divided by 3/4. So I need to find a way so that the 2 and the 4 can be the same. Now, one trick, usually the fastest way to find a common denominator is when you multiply the denominators by each other. In this case, if you multiply 2 times 4, you get 8. 4 times 2, you also get 8. However, notice that this 2 can be multiplied by 2, and then you get a 4, which would be a common denominator. So then you also multiply your numerator by 2. So then what do we do here? 6 times 2 would give us 12. 2 times 2 is going to give us 4. And then this is going to be divided by 3/4. So now we have a common denominator. And now that we have a common denominator, then we can do our model based on the first fraction. Now remember, when we do measurement division, we do the model based on the first fraction. So then I need fourths, right? And I need 12/4. So then this tells you that I have 1, 2, 3, 4. That's one whole, but that's not enough because I need 12 of them, right? So then I need to do one more. So 1, 2, 3, 4. Close it. That's also not enough because I need 12 of them. So I need one more. So 1, 2, 3, 4. close it, and that's 12. So then I need to shade 12. So I'm going to go ahead and shade them. Okay. So shade 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I need to break them into pieces of 3/4. See how many times I can break it into pieces of 3/4. So then I'm going to grab the first 3. 1, 2, 3. This is 3 out of 4. So this is 1 time. Okay. So then 1, 2, 3. This is 3 out of 4. This is 1 more time. So then 1, 2, 3. This is 3 out of 4. This is another time. And finally, 1, 2, 3. Again, 3 out of 4. And this is 1 final time. So how many times was I able to break this? So it's 1, 2, 3, 4 times. So therefore, my answer is 4. You will also notice that we talked about how when you have common denominators, right? Once you get them to have common denominators, then your answer, it's really in your numerators, because the denominators are going to cancel each other, but your answer then is in the numerators. And it's always your first numerator divided by your second numerator. And then you simplify this. How many times can you fit the 3 into the 12? Well, 3, 6, 9, 12, 4 times. So then my answer is 4. Okay. Okay, so number 2. For number 2, once again, the trick here is going to be for the denominators to multiply each other. If you get the denominators to multiply each other, you're going to get a common denominator. So for the 3, I'm going to have it multiplied by 5, and the 5 be multiplied by 3. Now, whatever you do to the denominator, you must also do to the numerator. So let's rewrite this. I multiply 2 times 5. That's going to give me 10. 3 times 5. That's going to give me 15. Divided by 2 times 3. That's going to give me 6. 5 times 3. That's going to give me 15. Now, you guys got to keep in mind that this 2/3, it's really, it's when I multiplied it to give me 10/15, this is an equivalent fraction. So 10/15 is an equivalent fraction to 2/3. 6/15 is an equivalent fraction to 2/5. So all we're doing is really just equivalent fractions until we get them to have the same denominator. So now we can do the model based on the first fraction. I need 10 out of 15. It's going to be a pretty big tape diagram. So I need 15 of them. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then I'm going to close it. Okay, and then I need to shade in 10 out of the 15. Okay, so I need to shade in 10 out of the 15. So let's go ahead and shade 1, shade 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all I have. That's all I need. So then I'm going to break those into pieces of 6/15. So then I'm going to grab 6 at a time. So 1, 2, 3, 4, 5, 6. That's 6 out of 15. So this, I was able to make one group right there. Okay, so 1, 2, 3, 4, 5, 6 up to here. So let's make another one. 1, 2, 3. 1, 2, 3, 4, 5, 6. So then it ends right here. Okay. Now notice that in this one, I was only able to shade 1, 2, 3, 4 out of 6 possible. There's 6 possibilities, but I was only able to shade 4 out of 6. So in reality, I don't even have 2 holes. I only have 1 hole plus this 4 out of 6. So then my answer then it's 1 and 4 out of 6. This can be simplified because the 4 can be broken in half, and so can the 6. So if I divide by 2, 4 divided by 2, that'll give me 2. That'll give me 2, and then 6 divided by 2, that'll give me 3. And this is my final answer there. Okay, now we know this because remember that at this point, when we have 10/15s divided by 6/15s, my denominators are the same. At that point, I already know that my answer are my numerator, so that's 10 over 6. Then I think to myself, how many times can you fit the 6 into the 10? The answer is 1. And you have a remainder of 4 over 6, but this can simplify to 1. and 2 out of 3. And there you have it. It's number 2. For number 3, we can see that the denominators are 8 and 2. This 2 can be turned into an 8 by multiplying it times 4. So I'm going to also multiply my numerator by 4. So then I keep my 7, 8 divided by, now I multiply 1 times 4, that'll give me 4. 2 times 8, that'll give me 8. Now notice that my denominators at this point, they're the same. So my answer is really just my numerators. This is my answer here. So my answer is really 7 divided by 4, which I can simplify. I say to myself, how many times can you fit the 4 into the 7? The answer is 1, and you have a remainder of 3/4. And this is my answer. Well, let's do the model to see if the model will match my answer here. Okay, now I'm going to do my model based on the common denominators here because we are doing measurement division. So I need 7 out of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Close it. And I'm going to shade in 1, 2, 3, 4, 5, 6, 7. And then I'm going to break those into groups of 4, 8. So then I'm going to grab 1, 2, 3, 4. This is 4 out of 8. Notice that I also shaded 4 out of 4, which is also 1. On the second one, notice that I'm not able to shade all of them. I'm only able to shade 3 out of the 4. So I was only able to make 1 and then 3 out of 4. So my answer is 1 and then 3 out of 4. Okay, so there's my answer there. Okay, so let's move on to number 4. Number 4, this is one of those where you can, the easiest way to find the common denominator is by multiplying each other. If you multiply each other, then the 5 will multiply the 4 and the 4 will multiply the 5. Whatever you do to the numerator, you also have to do to the, whatever you do to the denominator, you also have to do to the numerator. So multiply by 4, multiply by 5, and then 3 times 4, that would give me 12. 5 times 4, that would give me 20. Okay, and then 1 times 5 gives us 5, and 4 times 5 is going to give us 20. Now notice that at this point, I already have common denominators. I already know that my answer is going to be my numerators. It's going to be 12 divided by 5. So my answer here is 12 divided by 5. Now I can simplify this and say how many times can that 5 fit into the 12? The answer is 2. I'll have a remainder of 2/5. And that's my answer there. So if we want to do the model here, we're going to model after the first fraction. So we're going to do it based on my equivalent fractions here, the ones with the common denominator. So I'm going to look at the first one, and I'm going to base my model off of that one, 12 out of 20. So I'm going to need 20 boxes. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. So there's my 20 boxes, but I need to shade 12. So I need to shade 12 out of the 20. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now I need to break them into pieces of 5 20s. So then I'll grab 5 at a time. So there's 1, 2, 3, 4, 5. So this is going to be broken right at this mark. So 1, 2, 3, 4, 5, right there. Okay, so here this represents 5 out of the 20. But notice that I was able to shade 5 out of 5. This is equal to 1. So then I grab another 5. So 1, 2, 3, 4, 5. So I'm going to break it up right there. So I shaded 5 of 20. I'm basing it off of this one. But I was also able to shade 5 out of the 5 boxes. So I need to go for another 5 boxes. So 1, 2, 3, 4, 5, and it will be about right there. Okay, so once again, notice though that in this one, I was only able to shade 2 out of the 5. So I have 1 plus 1 plus 2 out of 5. So that's 2 and 2/5. There's my answer there. Okay, so let's go over to number 5. Okay, and number 5 is 5/4 divided by 1/3. So once again, easiest thing to do here is, remember, I'm doing the fraction that it's called measurement. So we're doing measurement division, okay? So then if what I need to do first of all is I need to find the common denominator. One trick to find the common denominator is going to be to multiply the denominators by each other. So this multiplied by 3, this multiplied by 4. Whatever I do to my denominator, I must also do to my numerator. So I multiply 5 times 3. That would give me 15. 4 times 3, that would give me 12. 1 times 4, that would give me 4. 3 times 4, that would give me 12. At this point, notice that my denominators are the same, 12 and 12. And therefore, my answer is in my numerators. It's 15 and 15. So then my answer then is 15 divided by 4. So then I can simplify this and say, how many times can I fit the 4 into the 15? And the answer is 4, that's 1, 8, that's 2, 12, that's 3. And I have a remainder of 3 out of 4. And this is my answer there. So it's 3 and 3/4. If I want to do a model, maybe I can do a little bit of a different model this time. If I put like a number line and then I go all the way, okay. So then I'm gonna do my model based on the first one. So I need at least 15 12s. So then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I need 15. So this is 1 out of 12. This is 2 12s, 3 12s, 4 12s, 5 12s, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And these are all over 12. All of them are over 12. Okay. Okay, are over 12. Are over 12. Notice that once I get to this mark right here, that represents 1 whole. Okay, that mark right there. So then I need to break them into pieces of 4 12s. And let's see how many times I can do that. Well, the first mark is going to be about right there. That's my first 4 12s. So that's 1. The second one is going to be at about 8 12s. That's another one. I need 4 again. So it's going to be at about the 1 mark, at about 12 out of 12. That's another one. But I need to do 1 more. So I need to actually add 16 out of 12. So I'm including this and this plus this, but I need to add 1 additional one. Notice though that I must stop at 15 12s because this is all I have. So I only have 1, 2, and 3, right? I only have 1, 2, 3 out of the 4 that I needed. So this is going to be 3 out of 4. So then my answer is 1, 2, 3, and 3/4. So 3 and 3/4. Okay. All right. So it looks like this is the end of this lesson. There is your problem set. So go ahead and ask any questions if you have any. If you find some value, give it a thumbs up, and I will see you on the next one. Adios.